Alright, so now we're quickly going to talk about similar triangles. I'll just explain to you what they are and what cool things we can do with them to help us solve problems. So first, a similar triangle. So two similar triangles are triangles that have all the same angles. Okay, so it doesn't matter about the sizes of the triangles, it's just the same angles. So these two triangles, they're similar because they have the exact same angles. This one has 20, this one has 20, 110, 110, 50 and 50. Alright, so that they're not the same sizes. This one's obviously bigger than that one, but the cool thing about them is that the ratio still stands. So it's the same ratio we learned in the last one. So I'll say, so ratio works. Okay, so the ratio thing works with them. So for example, as you can see, so it has to be a corresponding side. So for example, if we do the big triangle over the small triangle, you can say 8 over 4, which is this big side over this big side. Then we'll say the left side, we're going to say is equal to 6 over 3, because that's the left side in the big one and the left side in the small one. And then again, we're going to do the bottom bit. So it's going to be the bottom bit on the big triangle and the bottom bit on the small triangle. And if you stick all those into your calculator or just do them in your head, you'll see that each one of those is 2. So the ratio is true. So this entire thing is true, that if you put the ratios of the lengths of the sides of the triangle, then yeah, it'll all be true. So this can be really useful when we're looking for unknowns, which we'll see in the next problem. So for example, if one of the triangle sides is x, then we can use this rule to try and find what x is equal to. So we'll go down. You have to be careful that you're using the corresponding sides in the triangle. So for example, these two triangles here are similar, but they're not like flipped the right way in the same order. So for example, you can't just say 10 over 5 because that's the left one is equal to 14 over 9 because that's the ones on the right is equal to 18 over 7, because if you put those in the calculator you'll find out that that's wrong. What you have to do is flip both of them so they look the same first. So for example, you'd have to go like this. So you'd put 9 on the bottom, you'd put 7 on this side, 5 on this side, and then we'd have our 96, our 34 and 51, and then you could do the same on this side. Okay, so this triangle is already the right way up, so we don't need to do it. Now we can say that, actually we can't do it straight away, sorry. As you can see here, this angle 34 is in the bottom left, and in this one it's 51, and this one is 34, and this one's 51. So we're gonna have to take this triangle here and we're gonna flip it around. So I'll draw it in yellow, just flipped around here, so it's gonna be the same basic triangle. Okay, it's still this one, except now 7 is on this side, 5 is on this side. We have 96, the angle at the top, 51 is the angle at the bottom, and 34 is this angle here, and 18. Sorry, not 18, and 9 is what I meant to do. Okay, and now finally we can use the ratio. So we can say that 10 divided by 5, which is the big one over the small one, is equal to 14 over 7, is equal to 18 over 9. And you can see that this is correct. So you can only use the ratio that to that point was just when they're corresponding sides. So when they're in the exact same orientation, they're facing the same direction, the angles are in the same places, etc. Alright? Yes, that's basically it for just the rules of similar triangles. In the next video, we're going to look at 2 quick example questions using this rule.